The session is about introducing the Couchbase data platform. So before I start, can I ask you a question, like how many of you have worked with any of the NoSQL databases? Which one? Okay, you have worked with Couchbase? Okay, that's good. That's good. Okay, so what I'm going to do in the next 45 or 50 minutes is introduce Couchbase data platform and try to demo all the services that are running on Couchbase. Okay, so these are the topics for today. So I'll be introducing Couchbase data platform, talk about document versus relational model, and then talk about the Couchbase data access paths. Okay, talk about how gets and sets are done in Couchbase, talk about querying. We have nickel querying, and we talk about full text search. We also have an eventing service that is to do something more with the change. Whenever the document changes, I want to do something more about that. Okay, we also have Couchbase analytics. Okay, so I'll briefly overview about Couchbase analytics as well. So who am I? My name is Clarence, and I work as a global lead instructor at Couchbase, and I've been like a little over 4.5 years now with Couchbase. And I have about 14 years of teaching and consulting experience. All through my career, I've been a consultant, PS guy, and basically professional services guy and an instructor. Okay, I have a Ph.D. in computer science, and I'm a proud father of many dogs. Okay, so I'm a hardcore dog lover, and you can find me on Twitter. Okay, it's JavaPsych. Okay, the Twitter thing. Okay, let's talk about Couchbase data platform itself. So if you look at Couchbase, what's the product history? So there was a company called as there was a product called as Memcached, and you must be knowing CouchDB, right? So these both two guys met together in a conference in 2011, and Membase guys told CouchDB guys, hey, you're an excellent persistence layer, and CouchDB guys told Membase guys that you have an excellent in-memory layer. Why don't we get together and come up with a layer that a product that has a real good in-memory and a persistence layer. Okay, so that's how Couchbase was formed. So Couchbase was formed because of these two products in 2011, and ever since the direction has been completely different. So which basically means if you know CouchDB today, it does not mean that you know Couchbase. Okay, so after 2011, all the product directions have been completely different. We are moving a very different way. Okay, we did borrow their architecture, but the product movement was completely different. So if you look at today the data platform itself, so this is how a data platform looks like. So you can see you can deploy Couchbase on any cloud or container, which means you can deploy cloud on a Couchbase on a bare metal system. You can deploy Couchbase on AWS, DigitalOcean, Azure, GCP, or deploy it on Docker, which is managed by Kubernetes. We also have an operator for Kubernetes. Right. So on the top of that, you have elastic scalability, replication, and managed cache. So it has caching and the persistence layer. And on the top of that, you can see multiple services that run on Couchbase. So you can choose from choose services. Okay, you don't have to run all the services on a node. You can choose which service you want to run. Okay, and that's what is called as multi-dimensional service. You have the capacity to choose which service needs to run on a particular node. And on the top of that, you can see we have a unified programming model, which means you can choose from different SDKs to program with Couchbase. You can use the C SDK, you can use the Java SDK, Node.js SDK, Golang SDK, PHP SDK, Python SDK, and so on. Right? You have a number of SDKs that you can choose from. And you have several big data and data integrations available, and also cross-stack security, complete security accessible. So when you're writing to the memory layer, or from memory layer to the disk, or from one node to another node, or cross data center replication. So at any point of time, your data is completely secure. And on the top of that, we also provide you with something called as role-based access control, that is RBAC kind of thing. And it's one of the first NoSQL database that comes up with role-based access control. So looking at the high-level architecture, we have multiple services that are running. Okay, we have data service where your data runs. Your data is processed. We have the query service and the index service where you can run a nickel query to access your JSON documents. Right? I'm going to demo these. Then we have the search service for full text search. Okay, and eventing service. So to do more with the data change. and we have Couchbase Analytics also. So these are different services that run, and you can see for each node you have a storage and a cache and a process called as cluster manager that's running. Okay, and cluster managers gives a way how to manage your entire cluster. Okay, briefly let's talk about document databases versus relational models for people who aren't from a document database or who come from a relational model. So typically in relational model what happens, there's too much of normalization, right? So you normalize and normalize and normalize. So why do you normalize so much? For consistency and to avoid data redundancy. But it comes with a cost, right? So the cost of reading, you need to join on this table, on this table, on this table, and then you're getting the data, right? So there's a cost actually. So how do you avoid that cost is by denormalizing, or rather I would say relaxing the normalization. You know, that's the term which I like. Instead of denormalization, I say relax the normalization. So instead of you storing as rows and columns, you rather store it as JSON documents. And you can see a typical JSON document. If you do a mind mapping of how relational models are mapped to a JSON model, something looks like this. So have a look at this. You have a database here, and if you look at a bucket, okay, bucket is a unit of storage of data in Couchbase. So how is a data document stored? So if you look at user is a table, and you have two records here in user. So you can see two documents basically, right? So there's document 1 and document 2. So each row becomes a document, and your primary key becomes the key of the document, right? It's a key value pair, so it's a key of the document. So let's look at a little more. What about the columns? So if you look at the columns, how are they aligned? Each property within the each attribute within the JSON document is like a column, right? So you can see it's a different column, and this one is a different column. So now how do you identify the type of the database or the table? So how do you identify? You identify it by a attribute that's going to identify. So you can see this document is of type user, which means most of the attributes are going to be of the user type. So what about a different type? Show me a different type. Product. So look at this. So this is a user table, this is a product table, this is a user document. How do you know that? Because it has a type of user. Okay, what about this document? This is a different document. You can see the attributes are different now, right? And how do you know that? That's because the document type is product now, right? Show me a little more. Okay, how about the schema less or flexibility of the schema? So see, the advantage with NoSQL databases is schema flexibility, right? So you can see here you have product with these attributes. There might be another product document which has exactly the same attributes now. So look at this, same attributes, or it could be different attributes. So now you can see it's unlike the previous one which had quantity and stock, and this attribute, this document does not have quantity, so quantity is 0 and restock is true, which means the attributes are different now, right? So that's how you know, that's the basics of relational versus document models. Okay, so let's look at Couchbase access path in itself. Okay, that's something which I wanted to start off and start with the demo so that you can really feel how Couchbase looks like, and in case you haven't really seen how the interface looks like and so on. Okay, so there are 6 access paths, or how you can store and retrieve data. Okay, so you can get it and set it by the key, which is the fastest way, or you can run nickel querying. That is, instead of you running an API kind of way of retrieving data, we came up with a query language which is familiar to you. And what is that? SQL, right? So we bring SQL to NoSQL databases. So which means now you can write your same SQL statement and run it on Couchbase, and that SQL statement is going to parse your JSON documents and return results in the form of JSON, right? Full text search for full text search capabilities. Eventing. Eventing is when you want to do more when the document changes. I'm going to show a demo of that. And analytics. Okay, when you want to do analytical kind of workloads, you use Couchbase Analytics. And mobile, which is one of the first online offline kind of data management. So that's what is Couchbase Mobile. Okay, so let's look at get and set the data service. So Couchbase is memory first architecture, and the way how the data is written is the client application writes the data to the cache, and it's memory first architecture. The write and read always happens in the cache, okay, and as soon as the data is written in the cache, it is asynchronously replicated to different queues. It could be your intercluster queue, it could be your XDCR, that is cross data center replication queue, or it could be your persistence queue. It's going to be, the data is going to be pushed to these different queues and they would be processed accordingly asynchronously, right. Let me start off with a quick demo. So what I want to do right from the installation, I want to show. So I have a couple of machines that I have spun up on AWS. So what I want to do is right from the installation I want to show you. So let me open my terminal here. Let me open my terminal. Is that visible? It should be visible, right? Okay, let me open, let me SSH to one of my nodes. Let me SSH to one of my nodes, and okay, I want to SSH. Okay, let me log in as root. Oops, I did not SSH. Okay, one second. Yeah. That's because the PEM key was missing, and because that's not in that location. Okay, so yeah. All right, so it's logged in, and let me just go sudo -i and let me install Couchbase. Okay, so to do that, first let me just disable the swappiness. Okay, let me just disable the swappiness and install the wget to retrieve the RPM file. I just have copied this, and so that things become easier. So I just installed wget here. Okay, so wget is installed and I get the RPM. Okay, I download the RPM. Okay, and I just do install RPM. Okay, so all it takes to install Couchbase is only that much. Okay, so of course it gives a warning that you need 4 cores minimum, but I have 2 cores because I have a T2 large machine on AWS. I could have spun a different machine also, it wouldn't give that warning. That's okay. Okay, so all it takes to install Couchbase is that much. Okay, you download the RPM and just rpm-install, and it's installed. Okay, let me wait for a few seconds and let me log into Couchbase and set it up. Okay, so I need to log into 8091. That's the port. Let me see if it's done. I'm still waiting. Okay, it's setting up. Okay, so it's done. Okay, so I log into this and oops. All right, so Couchbase is not slow, the internet here is slow. Okay, all right, let me set it up. Okay, let me just say Voxxed cluster, and let me give password here as Couchbase. I agree the terms, and I give the and I tell what is the disk path and what's the index path, what's the analytics path, and so on. And I choose the different services that I want to run on this node. Okay, so if I'm setting up one node cluster, you can see these are the services that we discussed, isn't it? So what are services that I want to run on this node? So on multiple services that I want to run, or it could be only one service. So for this demo, what I'm going to do, I'm going to run only one service. Okay, that is data service, which means this node has the ability only to process and handle data. Okay, so all right, so let me just finish that, and that's it. So you can see that is what it takes to set up one node cluster, and if you go here, it is one node cluster, right? So how do I scale this up to a 4 node cluster? So at times I want to scale up, add more nodes. So I've already pre-set up these nodes, which means I've installed Couchbase, I've not set it up. So all I want to do is go here and add a server. Okay, add this, put the password, and what are the services that I want to run? Okay, I want to run only data service here. Okay, I don't want to run any other service. I add the node. Okay, and I want to add more nodes. Okay, I want to add more nodes. I want to add the 3rd node, exactly the same thing. So look at that, and there you go. I added the 3rd node. I want to add more node. Okay, more nodes. I want to add the 4th node as well. So what I want to do, go here and add the 4th node, and I also want to make this the data service. So basically I want to have 4 data nodes now, right? All right, and I have 4 data nodes, and what I'm going to do is rebalance, and that's it. So look at that, I have a 4 node up and running cluster. So I have a 4 node cluster now, it's completely up and running. Okay, so let me create a bucket. So bucket is a unit of storage of data in Couchbase. So let me just create a bucket, and let me just call it as sample bucket. Okay, and I give it some memory, say 500 megabytes per node, which means I have 4 node cluster, so it's 2000 megabytes of memory, and I choose Couchbase bucket, okay, which is persistent and disk only, and ephemeral bucket, which is only persistence, only disk only, only in memory, sorry, my bad. Okay, and let me add that. So okay, the data is being written, and let me just quickly write data to this. Okay, so that's the gets and sets. Okay, you have the key and value pair. So how I'm going to put data to this? I am going to run a random workload generator for that. So what I'm going to do here is I have already logged into a machine. Let me go to opt Couchbase and bin. Couchbase bin, and let me run cb workload gen. So hyphen b, the bucket name is sample, and bucket username is administrator, and hyphen p password is Couchbase, and hyphen JSON documents is what I want to write, and let me say hyphen I. So 1000 documents I want to write, or 10,000, or 100,000, or a million documents I want to write. Okay, so let me write million documents, and you can see here it's writing million documents now. Okay, a random million documents. So while it's writing, you can actually examine here. Okay, and you can see Couchbase is writing almost at 32,000 documents per second. Okay, that's pretty fast, right? On a T3 medium nodes, right? I have a 4 node cluster, T3 medium, and I'm able to get 30,000 gets and sets per second. That's ops per second. That's very fast, right? So that's how you can access. That's the gets and sets for Couchbase, and you can monitor. Okay, it's a complete monitoring tool. You can monitor each and everything. You can monitor the disk queues, you can monitor any indexes that are created, and so on. So let me quickly actually show you how to create indexes. Okay, that's the second way, that's the second access pattern, right? So if you look at the second access pattern, the first one that we saw was using the data service. The second way of accessing data is by nickel querying and indexing. So Couchbase gives you a language that you are already familiar with, which is SQL, right? So what I can do is, let me just go to sample and examine a document, okay, to create an index. So what I can do here is, let me examine a document, say 1000, and it says, okay, it's name, okay. So I want to create an index on name, okay. So when I want to create an index on name, I have to go to the query workbench, and when I click on query workbench, it says, oops, there's no query service that's running. Indeed, isn't it? Because all the nodes that I'm running here, look at this, these are running only data services, correct? So I need to have a node which is running index and query service. I'm going to add a node, right? So I'm going to add a node. So I have my set of nodes here. Let me add my 5th node, which is going to run now. It's not going to run my data service, rather it's going to run my index and query service together. Make sense? Okay, it's exclusively running index and query service. The other 4 nodes are running data services, while the 5th node is running index and query service, multi-dimensional scaling. So I have now the capacity to scale up this machine if needed, right? So I'm going to add this, and for high availability and scalability purposes, let me add one more. Okay, let me add one more node, that is my 6th node, which is also running index and querying capabilities. Let me just run index and query. I'm not running any other thing here, and let me add the node. Okay, all right, and let me rebalance. So when I rebalance here, so you can see here now there are 6 nodes. So you can see how fast it is, right? 6 node cluster, 4 data services, and 2 index and query nodes, right? So let me just go to my query node now. It says, hey, query node is present on these nodes. You'll have to log in there. All righty, let me go there, and let me log into the query node, and it's telling, okay, all right, so look at this, that's the query workbench, and I want to create an index. I want to create an index on name, right? So I'm going to say create create index. I'll just give it a name, okay, index on name on sample on which attribute? The attribute is name, right? So that's that. Can you see that? Okay, so it's a simple create index statement, and I'm going to create an index. And while the index is being created, of course, you can monitor, okay, where the index is created. The index is created on this particular node, and the index is not fully created. Okay, there's a build in progress. And of course, you can go to the buckets, which is this sample bucket, and look at the statistics on how the index is being built. Is it built completely or not? So I can go here and look at the index on name, and you can see whether it's built or not. So it's the memory used is this much, the data size is this much. On the disk, it takes so much space and everything, and there's 1 million items that's being indexed because sample bucket had 1 million documents, right? And let's write a execute a very simple query which we already know exactly the kind of way how you used to do. Let me just say a query which says select star from sample, right? And let me just say where name is equal to PYMC 1000, right, if I am not wrong. Okay, so simple query, and when I execute that, and you can see, boom, you get the result. Okay, in about 3 seconds you get the result. You are able to query, and you look at the beauty of this. You are able to query your JSON documents. It's not relational database. However, you are running a pretty SQL query that you already know on JSON. So you don't have to learn a new language or a new API kind of language to work with Couchbase. Right. Okay, what about these simple queries? Simple queries I understand. Okay, even there are so many other NoSQL database which can provide or run a simple query like this. Show me a little more. Okay, let's load another sample database. Okay, there's a sample database that's shipped with Couchbase which is called as travel sample, beer sample, and game sim sample. Okay, let me load beer sample and travel sample. Okay. So I have travel sample and beer sample that's loaded. So while it's loading, look at this. So travel sample and beer sample. So it's loading some data. Yeah. So there are about 35,000 documents in travel sample. So I'll just wait for 5 seconds for it to load, and I can run a pretty complicated query which has ANSI joins. Okay. So look at this. When I'm running a query here, so I can run a query here, okay, which is joining the destination airport and the airport.faa. Okay, so you can see here I'm selecting these attributes and I'm joining FAA and the source airport. Okay, and I'm able to run a query like this, which is exactly like your ANSI SQL query on Couchbase, and it's able to give exactly the same results. Okay, but in terms of JSON now, okay, because you're working on JSON documents. Does it make sense? All right, let's look at a little more different queries now that you know these. Okay, let's look at that's an example which I showed. Okay, so there was an airport document which had FAA, and there was a route document which had the source airport. So I'm able to join this and able to run this query. Right, I had to create these indexes which are pre-created actually, and I could run this query, which is the same kind of query that you would usually run on a normal relational database. Right, so it completely supports ANSI joins as well. Okay, so we are getting so close there. All right, so let's look at different service, full text service. Okay, so when you want to do text searches, so now you can see again multi-dimensional scaling here. So you have these data nodes, you have this query and index nodes, and you have a search node. So where you can create a search index, and based on the search you are able to retrieve from the data. So what is like a full text search? So full text search is something like this. See, the first step of full text search or a good full text search is text analysis. So if you have a text, what does it do? It first breaks it into tokens, right? And then it tries to reduce it to a common case. So you can see the one that is highlighted here. So it's trying to reduce to a common case, correct? And then it removes all the most commonly used or most frequently used words, right? Are you going to go to Amazon and search on has or some or on the? You wouldn't do that, right? So why do you want to index those terms? Absolutely, you're not going to search on those terms. Correct. So you want to only index the terms that are really important and which you would probably search on. and further you remove any stop words like beautiful can become only beauty, right? Colorful can only become color. And then what you try to do is remove into and merge to a common language. Instead of COLOUR, you try to use one common language. So you search for COLOUR or COLOR, that should appear in the search, right? You try to come up with an analyzed term, something like this. So that's how a simple full text search works, okay, which basically creates an inverted index. So if you are trying to search something like this, say colorful deadly beauty or something, so internally it's converted, analyzed, and it's converted to color, dead and beauty, and it's going to search in the index that you have, right? And how is the index created? The index is created in the inverted order. That is, you have an inverted index. Say for all the terms, it's trying to tell what are the document IDs. Okay, the term color is present in the document ID number 42 and 119. The term color is also present in the document ID 12, in 31 and 97, and so on, right? So these are the various capabilities of full text search. Let me show you a small demo of full text search. So to search, again I go to the search. When I click on search, it says, oh, you don't have search nodes. Indeed, right? We have only data nodes, we have query nodes, and we have index nodes. Let's add a search node. So let me go to which node, which was that? Okay, these four were data, index, and this one. Okay, this is my search now, right? So let me add a search node. So let me go to my servers and let me come here and add a server, and now I'm adding a search node, Couchbase, and I'm choosing the search service now. Okay, and okay, let me give some memory and let me rebalance, and now you can see I have a 6-node cluster or 7-node cluster with 4 data nodes, 2 index and query, and 1 search node, right? And let me go to search now, and it says, okay, search node is this one. Let me log into this one. All right, so that's my search node. Okay, alright, so I log into my search node. I want to create a search index. So I have my travel sample that is already loaded, right? Let's have a look at briefly how the documents look like in travel sample. So if I go to travel sample, it has 31,000 documents, and let me look at a particular document. I want to show you a particular document, so that because that's what we are searching. I want to look at the hotel documents. So let me just open this document and look at this document. Okay, so how do you know this is a hotel document? You remember the type has to be hotel, right? So the type attribute, can you see that? The type is hotel, correct? The type attribute is hotel, so that's why it's a hotel document. And look at this description. Okay, so this is the description on which I want to do some full text search. So I'll copy this. Okay, so Gillingham or something like that, Gillingham, and it's a hostel. So that's something that I want to search or something. Okay, so let me go to my search here, and I want to create an index now. So I want to create an index. So what's the index that I'm creating? I'll call it as hotel description. And on which bucket? I want to create on travel sample. So what's the JSON identifier? So identifier field is type field, and what's my type? Okay, what's my type mapping that I want to give? I want to add a type mapping. I want to say my type is hotel. Okay, and I want to index only those specified fields in order not to index all the fields. So I'm going to say okay, and I'm going to add a child field here, and what's the child field that I'm going to index is description, right? So I want only the description of the hotel's document to be indexed. That's what I mean, right? So description attribute, and I want to store this. Okay, and it looks okay to me. Let me say okay, and let me create an index. So once it's going to take some time. Okay, it's creating an index here. So okay, 100% created, and now let me search for something. Okay, so now that's created. Let me search for Gillingham hostel. Okay, so when I search for that, and look at this search, oh, look at that. Okay, so I have, based on the ranking, okay, based on the ranking, I have the documents on the top. So look at this. This document had the best match. It had Gillingham as well as it had hostel, right? So this document has been highly rated, so it's on the top. Well, this document had only hostel in its description and did not have Gillingham, so it's somewhere in the bottom. So in this document, okay, based on some other ratings, okay, this is also a hostel, okay, but it's not Gillingham, so it's rated. So in this way, you can see how Couchbase allows you to do a full text search. Okay, this is a very simple full text search. You have extreme capabilities. You can even do a faceted search. You know what is faceted search? So when you search on Amazon, say for laptop, you get facets here, right? Which says, okay, now that you search on laptop, what kind of laptop do you want, based on the brand or based on the CPU size or based on the RAM capacity or something like that, right? So that's what is a faceted search. So all such things are possible. So even while I'm scoring here, so look at this, I can even see the score here, okay, or I can see the advanced settings here and see this is the document, this is the REST API actually. So I can say, you know, basically this is the REST API that's generated. I can actually take this and run the curl command in the command line. So I'm going to show you that. So look at that, I just copy that and just run a simple curl, okay, just paste it and it should work. Okay, there is authorization thing required. So let me just put this to host -u administrator and Couchbase, okay, and when I say enter, so look at this, is the same search results that you're getting in command line, which means you can just use the REST API, and now that you have created an index, you can take the REST API and then search, right? So that's what is Couchbase search. Okay, let's do a little more with the change. Okay, and what are the features available in search? You have basic query types like the match query, you have the match phrase, you have the fuzzy search. Okay, you can search on compound range, you know, different types. Okay, you can search on Boolean, you can search on date and so on. You can search on different languages. Okay, you can do language aware text analysis. And you have industry standard scoring, okay, a proper scoring methodology in which you can retrieve the data. You have security as well as the REST API. Okay, so that's what is search. Let's talk about eventing now as a service. So I want to do more. Whenever the document changes, I want to do something more. Okay, how do I do that? And I can do that by using eventing. So eventing is a service where whenever the document changes, you can actually do something with that change. That is, maybe I wanted to update that document with something more, or I want to see whether it conforms to a particular schema. So what is an event? Any change or creation of a document or updation of a document or deletion of a document, or when the document gets expired. So that's an event, right? So what do I want to do with that event? So how can I do that? We have a closed version of JavaScript that can be embedded as an eventing programming language. Okay, so how do I do that? I go with eventing. So when I go with eventing, again it says, oh, there's no eventing nodes. So let me add eventing nodes. So you can see different services can be added independently. A lot of times I may not need eventing in my application, right? So okay, no eventing nodes. I don't have to mix all the services that are running. Okay, so let me just go to servers and let me just add the eventing node. Okay, and that's the eventing node. So look at that. So that's the eventing node. All right, it takes some memory and let me rebalance. Okay. All right, so there is eventing nodes, and when I go here, it says this is the eventing node where you have to go. All right, so let me just go to that node and try to log in. Okay, and what do I want to do is run a very simple function that I want to fetch all the hotels in United Kingdom, okay, and put it in a different bucket. Okay, bucket is a unit of storage in Couchbase, right? So no functions that are running. So what I want to do here is I want to create another bucket which is called as travel destination. I want to give some RAM for that. Okay. And let me also create a bucket called as metadata. Okay. So, metadata is a bucket that you need to create for eventing purposes. Okay. So, let me just create one more bucket. So, what is my purpose now? I want to fetch all the documents that belong or that are of type hotel and hotels in United Kingdom. I want to fetch those documents and put it to a different destination, right. So, how am I going to do that? So, let me refresh this one second. I don't know why this is still pending. Okay, meanwhile, let me just add a function here. So, add a function. So, when I am adding function, so what is the source bucket? The source bucket is travel sample. What is the metadata bucket? It is metadata. And what is the function name? I will just say hotels in UK, alright. And alias for travel destination, I will just say TD, okay. TD is my travel destination. I want to add my code. So, this is my default handler, that is. So, but I want to replace with this much. So, what I am trying to say is, if the document dot type is hotel, so if it is a hotel document and the country is United Kingdom, I want to take that document and put it to the destination bucket with the key as destination metadata, and I want to put the entire document there, right. So, let me just save this, okay, save this function. It is a very simple function and I want to deploy this function, okay. So, when I deploy, it basically asks for feed boundaries. So, what is your feed boundary? So, which basically means, do you want to, there are existing documents in travel sample, right. Do you want those documents also to go through this function, or do you want only from now? So, whatever documents you update from now, you want it to be considered. So, I want everything. So, I will deploy the function. So, while I am deploying, so you can actually see here, the metadata is for eventing, it is trying to update that, and let me just refresh, and you can see whenever the document gets updated, okay, only as of now only the hotels in United Kingdom are being put here. See, already you can see here the destination bucket is being updated with the hotels in United Kingdom, okay. So, it is processing that, okay. There are 31,000 documents processing that. So, basically each document is passed through that function, okay, and it is trying to search that and it is getting that. So, look at that. So, it is still writing. So, maybe about 350 hotels. So, if you just have a look at any document that is there now, so you can see here it is the destination, and if you look at any hotel, so that is the hotel in United Kingdom, right. And let me see if it is done here. Okay, there are many more. Let me see once it completely loads, okay. So that I can search for some other hotel and change. Okay, so there are 417 hotels here. So, let me do a thing. Let me go to my travel sample, okay, and look at a hotel which is not in United Kingdom. Say for example, I will look at a hotel which is in yeah, this is in France, right. Let me change that in to United Kingdom. So, just assume this is an application update, okay. So, I update that, and when I update, as soon as the update happens, so look at the document that changes here, it is 417, it became 418. So, because there was a document that was being updated, it automatically looked at that update, it went through that function, so it qualified the condition and it was updated here, right. So, that is the basics of eventing. So, I can just show you another function wherein I do not want to copy the entire function, rather I want to entire document, and I want to have only particular attributes. Say for example, here let me go to eventing. So, you have to undeploy the function, okay. So, remember, why do I need to deploy and undeploy? Because remember, we are working on a distributed system, it is not on one machine that is working, right. So, there could be like 10 eventing nodes that are working, and it is extremely challenging to work it in a scalable way, make it work in a scalable way, right. So, we need to deploy and undeploy. So, only when after it is undeployed, you can actually edit the script here, and I can write a typical function here. So, which basically says if the type is hotel, okay, I want to copy only these attributes, that is name, address and phone number. These are the only 3 attributes that I want to copy in that bucket. Okay. So it has way more power than what I am trying to demo here. Okay, we can directly embed nickel query here. Okay, and we have something called as callback functions. You can call back functions. You have timers. So that is, okay, after so much time, okay, I want to do something with that. So we have timers, and we are also coming with something called as PubSub. Okay, so publish and subscribe kind of model. It's not yet up, but it will come up. So let me save this and let me just flush this bucket. Okay, so there are already documents here, right? So let me flush this bucket. Flush is like truncate. Flush is like truncate, and let me flush this, and okay, so 0 documents, and let me just go here and deploy this function. Okay, so I want to deploy everything. So I'll just wait while it's deploying. You can see actually here in the buckets here, right, the metadata is being written, okay, as well as there will be some changes. So while the documents are written, you know, what I wanted to show you is, look at the documents. Now instead of copying the entire document, only 3 attributes are copied, right? Instead of the entire document, only the 3 attributes that you mentioned are being copied here, correct? So that's what is about eventing. Let me show you the last thing, that's analytics. Okay, so to do analytics, let me go to analytics, and it says, oops, no analytics nodes, right? Not everybody needs analytics, so no analytics nodes. So if I want analytics, let me add a node. So where's the node? I think this last node. Okay. Let me just add the node, Couchbase, and I want analytics here, right? So let me just run at this, and it says some memory, and let me rebalance here. And I have Couchbase Analytics node now. So you can see my last node is my Couchbase Analytics node, right? So let me just run analytics here. So it says analytics on this node, all right. So let me go there and run some analytics function. Okay, so look at this. So I have an analytics editor. So what am I going to do here is first create a data set. Your data set is in analytics is the set of data on which you want to analyze on. So what I'm trying to do is, I have a bucket called as beer sample. It has 2 types of documents, okay, brewery document and beer documents. Okay, so I'm trying to create a data set on breweries, on beer sample, where type is brewery. Okay, so I create a data set. Okay, so data set is created, and I want to create a data set on beers. Okay, so where type is equal to beer. So you can see I have created 2 data sets. You can see here on the right that I have 2 data sets here, that is beer and breweries. So that's it. Okay, and let me just run any query. So if I just run a simple query here. Okay, so how many breweries are there, for example? So if I say execute here, okay, it says 0, but actually there are. Okay, why it did not happen is because the data shadowing has not happened. So how does data shadowing happen? Unless I connect it, okay, I say connect link local, because I'm on the local cluster. If I can connect to a remote cluster also. So only at this point of time the data is shadowed. Okay, once there is a shadow data set that's created, any updates that happens to your actual data set, the data is automatically replicated to the shadow. So this is a very powerful feature. You know why? Because I do not have to do ETL. Okay, there's no extract, load, transform, right? See, if you look at even search, right, I didn't have to move the data away or across Couchbase cluster. Everything was happening within the cluster. So how about your analytics? It's happening within your cluster here now. Okay, now let me run my previous query, the same count of breweries, and when I see here, okay, now I have 1412 breweries. Look at that. That's an analytical query. Okay, that's a very simple query I could do in nickel, right? So what's about analytics? So nickel is used for simpler queries with simpler aggregations. Say if I want to ask, okay, give me the passenger details, okay, give me the passenger details and his last 10 passenger details or last 10 flights that he took, okay, that's a nickel query. But what about an analytical query? Analytical query would be something like, okay, give me the list of passengers who have been flying from January to February and have been flying for more than 10 times and have been flying business class, for example. Right. So, that is an analytical query, that is not a nickel query. So, you can see here I can run pretty much any kind of query, and here very important, I am not creating indexes here, right, because the way our analytics work, it does not need an index node, it does not need a query node, okay, there is an it's an MPP way, okay, there is an MPP database that is running internally which is doing, so massive parallel processing of data is happening and it is trying to retrieve the data. So, you can see here I am trying to run a query which is like this, or I can run a equi-join query, kind of query that you already know, it's a equi-join query, okay, which is running on analytics, and you can see without creating indexes or anything, I am able to run the same query on JSON documents, okay, or it need not be so simple query, it could be a nested join query, okay, so it's a nested outer join query, okay. So, you can see here there is a select and within that there is a select. So, it's not a very simple query, right. So, you are able to do that, and you can see here you are able to get the results of that query as well, okay. Or you can take this query, okay, it is even deeper and doing couple of things here, and you can execute that query. So, all those things are actually possible with Couchbase Analytics, right. Okay, so, let us quickly actually see when we look at analytics. So, analytics is also a service that runs on Couchbase, and when do you run query service, okay, for data manipulation from application logic or simpler SQL, or when you have smaller volume of data, okay, and when you want to do insert, update, mutations and all such things, actually you use the nickel or the query service. But when you use analytics is when you have historical or interactive dashboards, okay, when you want to really look, that is a huge volume of query that volume of data that needs to be processed by the query, right. So, that is when you go with analytics, and these are the features that are available. And the last thing that I want to discuss is the Couchbase mobile feature, okay. It is not a service that runs, we also have a product that is Couchbase mobile, which is the first industry's first online offline kind of application. So, basically you normally what happens if you completely keep your data locally, what happens if you lose your mobile, you lose your data, right. But what happens if you put everything in the cloud, okay, if you do not have connectivity, you do not have access to data, that becomes a problem. So, when you use Couchbase mobile, what happens, you have your data stored locally and you have your data stored on the cloud, and when does that data get synced up? So, whenever you have network connection, the data gets synced up, okay. So, you are able to give some really good user experience with Couchbase mobile, okay. So, by creating online and offline applications, a good example is like for your POC, point of sale machines and certain things like that, it's a best use case, okay. And these are the various features of Couchbase mobile, okay. And that's it from me, and if you have any questions, I am there to answer. Yeah.
Can you run the full text search and then on the result set compute analytics?
Yes, you can actually do that. It's not fully integrated though, but there are ways to do that. Yes, that can be done. And however, there is a new feature that is coming up with 6.5, this is 6.0, 6.5, where you can use full text search to run a nickel query directly, okay. So, you are using full text search index to run a nickel query, which is extremely powerful.
So, the new data which is added to your the database or from where you are getting this data out, so that process of indexing is offline or it's online?
It's all asynchronous. As soon as the data gets changed, the data is updated. There is a protocol called as DCP, database change protocol. So, whenever the data changes, whenever there is a mutation on the data, okay, it's created or updated or deleted, so it asynchronously updates the indexes, it updates the shadow data set, it updates the replication across the data center and everything, it takes care of that. You don't have to do anything. Yeah. No time, yeah. For XDCR, yes, maybe, because that's a network, right. And remember, the access is always in the memory. So, it does not matter if it is slightly slower at the disk also, because it is memory first architecture, right. So, you are always going to get the data which is there in the memory, and there is only one copy in the memory.
Do you have any plan to centralize the configuration of the settings? For now, you have to switch from one node to another if the full text search is not.
This is only in the console, but this is not true when your application has to do that. Because for an application, the cluster map is with the application. So you log into one node and everything happens on that node. So here I am just using the browser, right? So it is the browser, I would say, issue, okay, wherein I have to log into a different node. It's the session manual of the browser that's actually telling go to that node. Okay, but if it's application level, you don't have to log into a search node for running search query or something. Okay, you log into one cluster and you get the entire cluster map and you can run query on any, using that. That's a good question. What is your? Yes, we have partitioning of indexes as well. Okay, there's something called as create partition, partition by hash, and you give the partition key by which you can partition it, partition your data set. Yes, but partitioning is only done for huge data sets. Okay, it's not usually done for smaller data sets. See, that's the whole idea. We give you that way. You can choose what you want to do. You can always run search and data together also if you think so. I have seen customers with very small set of nodes, say running 4 node cluster. I have seen people running multiple services on all the 4 nodes. Right, that's possible, but people running 16 or 32 node cluster, they don't want to do that. They want to keep data separate from the indexes, from the query, and definitely from the search as well. But however, remember, it's all within the same cluster. Okay, there's no ETL that's happening. Correct? So we follow no ETL basically, right? So there's no ETL that's going on.
You were showing that there were at one point of time you flushed.
Yeah.
13 megabytes.
Yeah.
And when you loaded the documents, I think there were around 400 documents.
Yeah.
And it jumped to 30 something.
Yeah.
How do you explain that there is a usage of like 20 megabytes?
Yeah, the 20 or 30 megabytes is basically for the internal data stores. So if you create even an empty bucket, there's about like 50 to 80 meg.
After, when you load it, how do you explain the difference? Because we talk about 20 megabytes for 400 documents, which is quite actually huge. How do you explain that this is using so much? Whereas actually when you look at one,
you can actually look at the size in the disk here. If you actually go to your buckets here, and if you go to your documents, say for example, not documents, the statistics here. Okay, so if you want to know the real size of your documents, you can actually look at here document size. So you can see this is the document data size, this is the document size in the disk. Right, so this is your actual data size, not really this one, because this is will have some overheads also, right? Okay.
Is there a reason why you always do manual rebalance? Is there a way to configure?
Technically, you can write a script to rebalance automatically because we have command line version of doing that also. But however, rebalance should always be a manual operation. It shouldn't be automatic, right? Because you never know what's the load, because rebalance scales up or scales down the cluster, right? So you as an administrator, it's your wisdom, you look at the load on the cluster and see whether you can rebalance. That's one. Second is you can do multiple operations and rebalance once. You must have noticed for the first time I added 4 nodes and then did rebalance once. I didn't add a node, rebalance, add a node, rebalance, add a node, rebalance. I didn't do that, right? So I do multiple operations, like I can add couple of nodes, remove couple of nodes, and then do rebalance once. So that gives that flexibility of when to rebalance.
So if one of the data nodes fails, does it have any recovery strategy?
Yes, we do have auto failover. So of course I didn't have time to show that because I wanted to show all the services already, like she is like end. But I had couple of glitches with the internet, right? So I can take 5 minutes. So all right. And you asked about auto failover, right? Yeah. So node availability, you can see here. I can auto failover is enabled. So which means like I can configure it like 5 seconds the minimum. So 5 seconds if a node is down, okay, it's going to automatically fail over and the replicas on the other node will be active. Okay, so that's possible, and auto failover of groups also is possible. Okay.
During the search index, I guess we didn't talk about security, but I guess it's a security is configured when you're searching, you will just get out the results that you have access to.
Absolutely, absolutely. So here quickly, I can show you here when you're adding the security, when I'm adding the user here. So when I'm adding the user here, I can tell him what he can do and what he can't. So you can see here he is a searcher or something like that, and I can say on what buckets. Okay, so I create a user here, and not all buckets, but I want to give access to, give me a second. Okay, I want to give access to only sample bucket or travel sample bucket, correct? So he'll be able to search only on that particular bucket.
And at the document level, can I also?
No, not yet. No, all the attributes of the document, not at the document level. Yeah, that's correct, because our atomicity is at the document level.
We could imagine that, for example, that based on a certain criteria of the document,
Mm-hmm.
confidentiality level,
Mm-hmm.
a document is excluded from the search.
You cannot do that today. No. So that's when you'll have to probably put those documents in a different bucket. Yeah, that's a very good question. Yeah. Okay, thank you so much for attending. Appreciate it. Thank you.